In this video, we're looking at logarithms. This is a basic video explaining logs. So if we go to log base b, a is equal to p. What does the p stand for? So the b stands for base, the a is for the answer, and the p is the power. So we can rearrange that with b to the p is equal to a. So b is the base, p is the power, the exponent, and a is equal to the answer. Let's try and write that in a log form. So you will have to start off with log b to the answer is equal to the power. So relook at that and see if you can understand it. If we have 3 squared is equal to 9, see if you can rearrange it in the log form. So it will be log to the base 3, 9 is equal to 2. You can write down the following questions. We are going to do those. Pause the video, write the questions. Let's go. The first one, the logarithm of 1000 to base 10 is 3. See if you can rearrange it. The logarithm of 1000 to base 10 is equal to 3. The logarithm of 1 million to base 10 is 6. Log base 10, 1 million, is equal to 6. The other two you can solve using the same ideas. Let's look at A and try and make 1000 to 10 to the power 3. So 1000 will be 10 to the power 3. There is this rule that when you have an exponent like 10 to the power 3, looking at the 3, you can take that 3 and place it in front of the word log. Now when you have the situation log to the base 10 followed by the same number 10, so we have 10, 10, this will become always a 1. So when we have base 10 followed by a 10, or for example base 5 followed by 5, this will always become a 1, all of it in the rectangular green box. 3 times 1 is equal to 3. Note the answer on the top was 3 and this answer is 3. Hope you understand. Do try the same idea with B. Okay, you will have to break the red 1 million into 10 to the power of something. See if you can get that right. 10 to the power 6. Next step will be to take that 6 and place it in front of the word log. Again we have the repeating situation, log to the base 10, red number 10, 10, 10, thus all of that in the rectangular green rectangle will become 1. 6 times 1 is equal to, note we get the same answer. Right, hope you understand. You can continue with C and D following the same example. Okay, do write these questions down. Pause the video. We will do A and B. C and D is for you to attempt. Do write these questions down. Pause the video. So the logarithm of 32 to a base 2. So this means it's going to be log base 2 followed by 32. And that's how we write it. We can actually break that 32 down. So 32, think of 2 to the what power can give you 32. So we know it will be 2 to the power 5. Bring the 5 in front. What will really be the answer to that question? So bringing the 5 to the front, log 2 will give us 1. 5 times 1 is equal to 5. Let's attempt the next one. We have 64 to a base 2. So it will be log 2 followed by 64. See if you can break 64 to 2 to the power of something. 2 to the power of 6. Next we'll have to place the 6 in front. Log 2 will give us a 1. 6 times 1 is equal to 6. I hope you're understanding these basics. Pause the video, write down the following questions. Both of these are in exponential form. We will need to write them into a log form. Pause the video, try it out. Underlined in green is the base. Notice that the power is on the other side of the equal to sign. The power will be on the right hand side of the equal to sign. And the power for both those questions is 3. Notice we have to write the answer, the A value. Okay, notice it's as simple as that. Log to the base followed by the answer is equal to the power. And that is how we do it, as simple as that. Next we're going in reverse. We are going to look at being given the log form and we have to put it into an exponent form. So we're doing the reverse of what we just did. Remember to convert it. We have the base to the power is equal to the answer. Looking at the questions, see if you can work out which is which. The bases are underlined in black. The answer is underlined in green. And the power underlined in red. See if you can rearrange it. We have base 4 to the power 5 is equal to 124. 1024. The next one, pause the video, try it out. So we have base 6 to the power 3 is equal to 216. If you were to take out a calculator and punch in 4 to the power 5, you will get 1024. 6 to the power 3, you will get 216. Pause the video and write down the following questions. The question says we have to convert it into a log form. Underline your numbers and then do it. Pause the video. Let's start with the base. Log of the base followed by the answer. Note that the base is 9. This will be equal to the power. The power is minus 3. If you were to take your calculator and punch in 9 to the minus 3, see what you get. Do you see that the answer is correct? Because we know log 9 followed by 9 will give us 1. And minus 3 times 1 is minus 3. Correct. Notice I'm moving on to letter C. Rearrange in exponential form. Rearranging it, we'll have base 4 to the power minus 5 is equal to 1 over 1024. If you take your calculator, 4 to the minus 5, notice it's equal to 1 over 1024. Write the questions down and pause the video. So here we have to write in an exponential form. A, we got base 3 to the power 81 is equal to x. Base 3 The power is 81. The answer is x. See if you can do the next one. Pause the video. We have base 2 to the power x is equal to 128. 2 is the base. X is the power. 128 is the answer. Do attempt the other two. Do write down the questions. Pause the video. Solving for y on our calculator, 4 to the power 3 is 64. If you were to write that in a log form, what would be the base? Log to the base 4. Log to the base 4 followed by the answer is equal to the power. On your calculator, go 5 to the 2, 5 to the 3, 5 to the 4, and so forth until you can get something to the base 5 for 625. So 5 to the power 4 is equal to 5 to the x. Both the left and the right look exactly the same. Therefore, the x must be equal to 4. Substitute x is equal to 4 into the question. And on our calculator, that is correct. If you were to write that in a log form, it would be log to the base 5, followed by the answer is equal to the exponent. I could further solve that if I wished. 6 to the 25, we've already established that that is 5 to the 4. Move that 4 in front. You will get 4 log 5, 5. So all in the brackets will be 1, and 4 times 1 is 4. Notice that x is equal to 4. Let's look at my example. So my example says log to the base answer. Okay, so now we're going to introduce a log. Let's call the log we introduce, since we have a and b, let's call it log c. That log c could be log 10 over log 10. Okay, for example, it could be log 2 over log 2. You get the idea? So now, where does the base go? The base goes in the denominator. And where does the a go? The a goes on top. Let's look at an example with numbers. See if you can reposition these numbers as explained above. So we introduce the log, let's say log 10. Where am I getting log 10 from? From my head. It's one I thought of. Where does the base go? In the denominator. Where does the a value go? A value goes in the numerator. Hopefully that makes sense. Next we're going to be looking at the first rule. Let's look at this example. Notice that brackets mean multiply. So split this using the rule. When we multiply, we add. So all we do, we repeat the log with an add, and we take the numbers 8 and 64. As simple as that. Now we could solve this using the rule. Break the 8 and 64 into 2 to a certain power. Try that. Okay, looking at this question, we got log to the base 2, 8 times 64. So first step here is to separate it using the plus sign. When we see multiply, we add. Right? We can break down the 8 and the 64 into base 2's. 2 to the what power will give us 8. So 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 3. 2 to the 4 is 16, 2 to the 5, 32, 2 to the 6, 64. We can move those exponents to the front of the logs. And then we can have log 2 log base 2 to 2. Now remember, when we get log base 2 followed by 2, a repeated 2, what happens? All of that becomes 1. When we get a repeat, it becomes 1. We still have 3 plus 6. So 3 plus 6 is equal to 9. Let's go back to the top question and multiply 8 times 64 just to test it. 8 times 64 will give you 512. Break 512, 2 to the power something. Try with your calculator, 2 to the 7, 2 to the 8, for example, and continue until you get 512 on the screen. So 2 to the 9, move that 9 in front. So moving it in front, we get a repeat, log 2, 2. That will become 1. 9 times 1 is equal to 9. Next, we're looking at the next exponent law, and we're going to do an example on this one. Remember, when we see division, we subtract. So remember, we subtract, placing the 8 and the 64. Next, we want to think of powers that can work there. 2 to the something power. Is it making sense? Same numbers as last time. Moving the exponents to the front. Log 2 followed by 2 will give us 1. So we're going to have 3 minus 6. 3 minus 6 will give us negative 3. Right, let's look at the question that was given. Let's divide both the numerator and the denominator by 8 to make an equivalent fraction. Now see if you can write 1 over 8 as an exponent, 2 to the negative something. So remember, with exponent laws, we have to push that 2 to the 3 up to the numerator. It will become 2 to the minus 3. Take that minus 3 and push it to the front. Remember that log 2 followed by 2 will become 1. So minus 3 times 1 is minus 3. We get the same answer. I hope this makes sense. This is just the basics of logarithms. I will make another video with more detailed questions.